So here's example 4. We're going to be finding the area between x equals y squared and x equals negative y squared plus 8. So I've taken the liberty here of graphing our two functions. These are both horizontal parabolas. Here's x equals y squared. All right, opening to the right there, vertex at the origin. And then here in the navy blue is negative y squared plus 8. So vertex over at 0, 8 and opening to the left. Then on the graph, you can spot the intersections, but you can also use our intersection trick of setting the two functions equal to each other and solving for y here, y equals plus or minus 2. So you can see we get intersection points at 4, negative 2 down here and 4, positive 2 up there. So that'll be handy to have. You can also see from our graph the area that we're really looking at. It's all of this kind of lumpy rugby ball shaped area in here. Okay. And so when you look at a problem like this, you got to decide whether you're going to integrate in terms of x or in terms of y, whether you're going to use the vertical rectangles or the horizontal rectangles. And so here, if we were thinking to do this in terms of x, so integrating with respect to x, dx means you're taking tiny little changes along the x direction, and you're going to integrate like that. So we can see the limits are pretty clear. You'd go from 0 to 8. But then the functions that you'd be subtracting, the top minus the bottom, would get a little more complicated. Because over here to the left of 4 in this area, you can see that really only the black parabola, x equals y squared, that's the only one that's active over in that region. So you'd have to split that parabola into its two halves, positive square root of x and negative square root of x, and then integrate the difference between those. Okay, which is doable. Then over here on the right-hand side, to the right of 4, you'd have to take the two halves of the navy blue parabola, the negative y squared plus 8, and take the difference between those and integrate that from 4 to 8. Again, doable, but perhaps not ideal. All right, so if we switch and we integrate with respect to y, that means you're going to take little changes in the y direction and stack up like this. Okay, so when we sketch out that idea, we can see that again, there are clear limits on our area. We're going to go from y equals negative 2 to positive 2. Okay, that's where you stack those up. And then also, we're only going to need one integral if we do it that way, because there's a very clear right function versus left function. Okay, so that's really what makes the difference there, is that right versus left is nice and clear for that whole area, and top versus bottom was a little less clear, and you would have had to split it into two integrals. So we're going to integrate this with respect to y. And here is our rightmost function. So we're calling that xr for on the right. And that's negative y squared plus 8. And then this guy is going to be our left function. And that's x equals y squared. Okay, so to set up our area integral, we're doing everything in terms of y here, so the limits as well, they go from y equals negative 2 to y equals positive 2. Okay, so negative 2 to 2. Take your right function, negative x squared, or negative y squared, whoops, that's very important, negative y squared plus 8, and then minus your left function, which is y squared, and we are integrating with respect to y. So whatever your variable is in the with respect to part, how we have y here, everything else in that integral better be in terms of y, otherwise it's not going to work out so well. So if you had dy here, but these functions had x's, that would be a problem. But we're good to go here. So let's see what's really inside that integral. Simplify a little bit. Actually got negative 2y squared plus 8 dy. Not too shabby. Or if you would have done dx, you would have had a bunch of square roots and two different integrals. So this looks pretty darn good in comparison. All right, we can take the antiderivative of that. That'd be negative 2/3 y to the third, and then plus 8y. And we're integrating from negative 2 to positive 2, and we'll plug those guys on in. There's 2. And then subtract and plug in negative 2. Okay. So there we have negative 2/3 times 8 plus 16 in the first set of parentheses. And then, let's see, we would have negative 2 to the third is negative 8 times another negative 2. Well, I guess I'll just write it like that, minus 16 there. Okay, so we'd have negative 16/3 plus 16, and then this would be another 16/3 right there, so we're going to be subtracting that, 16/3, and adding another 16. Okay, so we would have negative 32/3 plus 32. Okay, that's negative 32/3 plus 96/3. And so we would end up getting 64/3 for our area there. 64/3 units squared. All right. And here, once again, it is kind of important to emphasize that when you're doing these area between curves integrals, it's really not net area in this case. It's like the actual total area in between there, because, you know, if you were looking at this in terms of net area, those two would balance each other out and you'd get 0. That's not what we're doing here. So we're looking at the total area. You can think of like absolute value of all that area. So that's how we get 64/3 there.